All right, Jody works at the towel factory and she earns $8.50 an hour. So if she works 0 hours, she doesn't get paid, so she earns $0. If she works 1 hour, she makes $8.50. If she works 2 hours, she's going to make $17. If she works 3 hours, she's going to earn $25.50. And if she works 4 hours, she's going to earn $34. And we're asked to describe what happens to her pay when the number of hours she works increases by 1 hour. So her pay then increases by $8.50. So every hour she works, every additional hour she works, she earns another $8.50. Now, in this question, you have to, we're going to graph it, but first of all, we have to identify which is the dependent and which is the independent variable. And we have to figure out if number of hours worked depends on pay or whether pay depends on number of hours worked. And the correct answer is, since number of hours worked determines what you're paid, then pay is the dependent variable and number of hours worked is the independent variable. So number of hours worked is the independent variable and pay is the dependent variable because pay depends on the number of hours she works. And if we're going to graph this, then what we're going to do is put pay on the vertical axis, and we're going to put number of hours worked on the horizontal axis. And we're going to title this Jody's pay. And if she works we got to go from 0 up to $34. And what we can do is, if we go up by $8.50 every other one, so we're actually going up by $4.25, then we can graph right on the line because they're all multiples of $8.50. So, sorry, that's $17. This is $25.50. And this is $34. And we're going to go over to 4 hours, so we'll go skip every other one. So if she works 0 hours, she gets $0. If she works 1 hour, she gets $8.50. 2 hours is $17. 3 hours is $25. 4 hours is $34. And the points here all lie in a straight line. So there's our graph for Jody's earnings. And the next question, it says, use the graph to describe the relationship between her pay and the number of hours she worked. So as number of hours works increases, so does pay. So what we say then is, as number of hours worked increases, pay increases. And the next question, describe the shape of the graph. The points lie in a straight line, so this is a linear relationship. And next we're asked to calculate the first differences in the table. And here we're going from 0 to $8.50, so that's a first difference of $8.50. And 17 minus $8.50 is $8.50. And $25.50, subtract 17 is $8.50. And $34 minus subtract $25.50 is $8.50. And so it says, what do you notice about the first differences? And what you should note is that first differences is equal to the hourly rate. Okay, and when the number of hours worked increases by 1, pay increases by, and every so $8.50 because every hour she works, every extra hour she works, she earns another $8.50. And once again, it's a linear relationship. First differences are the same. The slope of the line, we can take any points we want on the line here. And if we go from 850 up to 2550, and I'm going to change colors here. And so we're going to through these 2 points, figured out the rise and the run. So 850 to 2550 is a rise of $17, and the run is going from 1 hour to 3 hour is 2 hours. 17 divided by 2 is 8.5 or 8.50. And what you should realize is that slope is rate here, and the rate is the hourly rate that she's paid. The y-intercept is 0, and so the equation of the line is in y equals mx plus b form. Y equals mx plus b. We sub in m is slope, so it's 8.50, and x plus 0, so we could just leave it as that, or we could also write, instead of putting pay, instead of y, we could put in earnings, E for earnings. Earnings is equal to 8.50 times H, which means, or number of hours worked. So her earnings are equal to $8.50 times the number of hours she worked. Now, just coming back to these questions here, the thing about first differences is that anytime you see constant first differences, and here this is constant at 850, then we know that it's going to be a linear relationship. So this is the key, that when first differences are the same, the relationship is linear. Slope is 850, and the first differences are all 850 as well. So the slope and the first differences are the same thing, and they both refer to a rate.